All right, hi and welcome to another installment of Math Basics with Mr. Besh. Today we're going to use our prior knowledge and skill to find the missing side of a right triangle, and we're going to do this by using the Pythagorean Theorem. First, some background knowledge before we begin. We need to work with right triangles and only right triangles. You see, the Pythagorean Theorem doesn't work with any other type of triangle. The Pythagorean Theorem is a squared plus b squared equals c squared. Remember, the number in the upper right-hand corner is telling you to take each of the values and multiply it by itself. Now, what you want to do in your problems is rotate your triangle around in such a way that it mimics or models the one that I have for you. In this model, the height of the triangle is going to be labeled as letter A. The base of the triangle is going to be labeled as letter B. And the longest side, the diagonal side, is going to be labeled as C. Now, they have names in the math world. You see, A and B are referred to as the legs of the right triangle, and C is known as the hypotenuse. Now, the other symbol that you see in the slide is the square root. We will be using the square root on each and every problem at the very end. Every Pythagorean Theorem problem ends with the square root. And remember, this is the exact opposite of taking something to the second power. So, using a couple examples here. This first example is when they give me the two legs, but I'm trying to find the hypotenuse. Notice my height is 6 and my base is 8. Remember, in our model, the height was represented by A. So the first thing I do is take my height, which is 6, and square it. Multiply it by itself, I get 36. Then the formula tells me that I add b squared to it. B value is 8, so 8 times 8 makes 64. Now I take these two values, add them together, and that makes 100. Now, what this means is that 100 is equal to c squared. Now, I'm not trying to find c squared. I'm trying to find c. So now what I need to do is take the square root of this 100, or better yet, ask myself, what number times itself makes 100? And that is my missing side. My answer to this problem here would be 10. Remember again, very important that you match up the numbers with the right letters. C is always the longest side and will always be by itself on the right-hand side of the formula. A and B have to be on that left-hand side. And in reality, A and B can be flip-flopped, but as long as you make sure you get the math correct. Okay? My second example is one where we're missing a leg of the triangle. In this example, we are missing A. So now, to do this is done slightly different. The first step I have to do when I'm given the hypotenuse, which is 5, is take and square that first. When you know the hypotenuse value, you always want to find out what c squared is first. So 5 times 5 makes 25. The next thing that you need to do is take the other number that they give you, the value of the leg, which is 3, and square that. So 3 times 3 makes 9. Now, the technique is you take the hypotenuse squared minus the leg squared. So then 25 minus 9 makes 16. Now we take the square root of this value. The square root of 16 comes out to be 4. Notice the difference between the last example. The last example, we took a squared and b squared and added them together because we knew the two legs. This one, we're missing a leg, so what we had to do was subtract the squared value of the leg from the hypotenuse squared. Okay? Last example I want to do for you is this. Type of question pops up every once in a while. Could the following three values be sides of a right triangle? Notice my numbers. To do this, what you need to do is plug it into the Pythagorean Theorem. Because like I said in the beginning, the Pythagorean Theorem works with only right triangles. Well, vice versa. To determine whether three numbers represent a right triangle, they have to work in the Pythagorean Theorem as well. So what I need to do is take my three values and put them into the Pythagorean Theorem. Remember the trick. Looking at your numbers, the biggest number needs to go in place of C. So now my three numbers are 21, 35, and 28. What I need to do is I need to take and put those values inside my formula. So 35 needs to go in there for C because it's the biggest value. 21 and 28 really do not matter. You could put 21 here and 28 there, or vice versa, 28 first and 21. And you want to do the math. And if the left side of the equal sign is the same as the right side, then you're exactly right. And when I take 21 to the second power and I add that to 28 to the second power, I get 1,225. Now, when I take 35 to the second power, I also get 1,225. So now, as a result, this means because the left side and the right side have the same value, then these could be three values of a right triangle. If the math didn't work, then the answer would be, in fact, no. That's the Pythagorean theorem, folks. I hope you found this both helpful and informative.